Okay, the idea with this tutorial is to introduce some ideas surrounding additive synthesis, which, as it says here, at its most basic level simply means adding several oscillators together, which we are doing here. So we've got cycle, saw, triangle and rectangle wave, and we're adding them together by mixing them using these gain controls. So I can mix them by just choosing a balance of gain, and we have a timbre emerging which is a slightly more interesting timbre than these various oscillators on their own, although potentially a little bit irritating if I leave it going. And in fact you'll find that this kind of simple mix balancing between oscillators is not uncommon. So if we were to open a more commercial synth within Logic, you'll see that in addition to the various ways of filtering and enveloping the sound, you've also got this balance, which is exactly what you've seen in the patch that I've built, a means of balancing these various oscillators. But in this case, the relationship between the oscillators is fixed. So once I've set a balance, the balance remains until I change it manually by choosing a different balance of gains. Perhaps it would be interesting to have a way of dynamically changing the relationship between these various oscillators over time, which of course we can do by using gain controls, and we've already looked at gain controls through the line and the function object in the last tutorial. So we'll do that, we'll do it in stages as usual. So if I move on to this part of the patch, it says, let's start with a single oscillator. The following should be familiar to you. We make a tone change in amplitude over time by using the function object. So we have the cycle object, which is running through a multiplication object, and that is receiving data from line in order to change the amplitude. So if I draw in an envelope into the function object like we're told to, and then press the button object, you will hear that timbre play according to the envelope. What can we do in addition to that? Well, our frequency is fixed at the moment at 440 Hertz. A more useful synth would have some means of changing the pitch, so we can add that very easily by adding a K-slider object. And we'll need to convert the note numbers that it's spitting out to frequencies. So I'll do that. And I'll use the output of these note numbers to trigger the envelope. So we'll lock the patch. And now when I press notes, each of those notes is affected by the envelope that we've got in this function object. So what else can we do with this patch? Well, at the moment we only have one sound playing, and once again that's a sine wave. But if you add sine waves, then you can generate timbres which are much more complex. So if we understand the idea of harmonic or inharmonic partials and how they contribute to the timbre of a sound, you can use that information to generate more interesting additive timbres. So let's do that. I'm going to need a bit more space, so I think I'm going to have to delete all this stuff. And I'm also going to reduce the size of this envelope because we will need a bit more space. So I'm going to duplicate a chunk of this. So now we have a second sine wave, but of course if I were to just play that at the same time as this one, playing the same pitch, then it's just going to make this sound louder. So we will modify the pitch so that it will play a different pitch at the same time, and I'll do that by multiplying the frequency that's coming from the M2F object, and of course by doing that we get an octave above. And I'll use the same way of triggering the envelope. So if I lock the patch and play that, then we get both octaves playing at the same time. And of course, while the envelopes are the same at the moment, we could modify the envelope of the octave above so that the timbre seems to evolve as it progresses. And this is something which I think is quite important for a synthesizer. You want to generate timbres which are evolving. It makes them sound a lot more lifelike. And so we can continue this process by adding more oscillators. So if I unlock that patch and duplicate this again, and I'm using the same method as I've used in the past and possibly pointed out, which is once you've selected a portion of your patch to duplicate, if you press Alt and drag it, but then don't do anything else before pressing Command D, then it will replicate the part of your patch that you copied at the same relative distance from what you've just copied. So that's quite a neat way of keeping things spatially aligned when you're copying things. So we've now got 5 oscillators, and in the same way as I multiplied this second oscillator by 2, I'm going to multiply the next one by 3, and then by 4, and then by 5. Why am I doing that? Because that keeps these oscillators within the harmonic series. So, and in the same way as I did before, I'll connect all of that to the M2F and then to the envelopes to the trigger. Once again, I will change the envelopes of each of them so that my sound is able to evolve through time. So we should hear the timbre move through those various harmonics as the note progresses. Okay, it's a little bit loud, so let's turn down the gain. That's always the risk with adding timbres, is that of course you end up with distortion. So when we first hear the note, when I play it the first time, you hear that definite rise through the various harmonics of the series. When I play it at a different pitch, your ears start to make those pitches coalesce into more of a timbre than a sequence of individual sine waves. So from a very simple engine, we've got a means of generating a much more complex timbre, and of course you could keep adding these harmonics to make it even more complex. What else could we do to that? Well, we can do some of the things we've already done in previous tutorials. We can set the domain length of all of those function objects, which will allow us to change the length of that note. So it's by default it's 1000 milliseconds, but we could also make it longer and longer still. So we'll make it 5 seconds long. So I click on 5000 and we get a longer timbre. Something we could also do is make the loudness of the overall result relative to the velocity with which we hit the key. Now the last time we looked at making our note loudness relative to velocity, we used divide by 127. I think that was in tutorials 3, and connected that to the velocity outlet, and then connected that to a multiplication object down here. Well, we can't do that this time because of course we're using these function objects to control the envelope. So what we need to do perhaps is to control the range of these function objects so that they output the relevant peak loudness into the multiplication object that we've got down here. So we've already looked at setting the range of the function objects, and we'll do that again. This time we want the lowest value to remain at 0 because silence is silence, but we could have a variable peak loudness. So I'm using the $1 command as usual, and if I connect to divide by 127 and connect into these envelope objects, then that should give us our velocity control as well as our pitch control from the keyboard. So if I press loudly, we hear it quite loud. If I click at the bottom, which is represents quieter sounds, then we hear it quieter. So we have a way of controlling our relative loudness and an awful lot of cable clutter. So how might we clean that up? Well, this is probably less important now than it would be later on, but I'm going to do it anyway. So I'm going to use the align command. I'm going to choose all these cables that I want to tidy up. I'm going to arrange and auto align, and that lines all of these ones up so it all looks rather neater, and I can do the same thing with these ones. I'm going to move these button objects slightly to the right hand side so that we don't get confused between these cables and these ones. And that'll do for now. And maybe we can turn our attention now to the available oscillators we're using. So when we looked at the previous example back here, we had the option of, well, yeah, we did have the option of 4 different oscillators. Well, perhaps we'd like to have the same option of a variety of oscillators rather than just using the cycle objects. Well, for this perhaps we can borrow from a synth that we've made previously. So if I bring that up, here we've got a series of oscillators with a means of choosing between them. So this is the only part of the patch that I actually want to borrow. So I could just copy this whole section and paste it into here, but it's a little bit big, so it's going to take up too much room. So I'm going to encapsulate part of that. I'm going to choose the just the oscillator parts and go to encapsulate. I want to keep my U menu outside because I want to be able to control what's in there. It's just I don't want to see the oscillators themselves. So I will call it OSC for oscillators. And we now have just a controller and our various oscillators in a simple encapsulated patcher. So if I now copy this section into here, then I can replace the cycle object with that oscillator patcher. And we can then, of course, copy these across to the other oscillators. So we have a series of different oscillators for each of the different partials. So as long as I turn those on, I can choose a sine for that one, a saw for this one, square for this one, triangle for this one, and go back to a sine for the last one. And then hopefully we will get, now we get an evolving timbre which goes through those various oscillators. Another thing we can do, we can explore different harmonic relationships or inharmonic relationships between those various partials. So instead of them being stuck rigidly to the harmonic series, we could add number boxes here which permit us to change those relationships. So instead of it being 2, I can make it something else. Oops. So all of these will be different pitches in relationship with the original sound. All of which make it kind of interesting. One thing you might want to try, by the way, with if you do want to stick to the harmonic series, is to make these pitches very close to the whole number ratios that you would expect, but slightly offset. And this adds an element of detuning, which, because of various phase relationships and the potential for beating, will increase the richness of the sound that you get. So we could put in 2.001, we could put in 2.998, and so on. So so that this one here is close to 3. Make one that's close to 4, so 4.01, and this one might be 4.983. So they're all close to the whole numbers, but they're not quite. And again, this might produce a... So it's very similar to what we heard with the whole number ratios, but it's slightly more rich. Now, changing all of these manually is a bit of a pain, so we can use the preset, which I haven't talked about in the tutorial yet. I have talked about it in relation to the phase test that we looked at. So the preset object looks like that. It's got a series of nodules in this kind of grid. What that allows you to do is to save the state of the graphical user interface objects in your patch. So what you do is to simply connect the left-hand outlet to anything you want to save. So I'm going to connect it to all of these number boxes here, because this preset object is simply going to control the harmonic relationships between the partials. I'm going to use a different preset object to control the envelopes, and a further one again to control the choice of oscillators. So I'm going to choose number 2, and I click on it while pressing Shift. So when I've done that, you'll see that the nodule has changed colour slightly, and I can choose. Let's go back to my whole number ratios. And now I will do the same thing for nodule number 1, so Shift and click the first nodule, and then I'll make some crazy relationship for the other partials. They're all sort of within the 3 and 4 range. Actually, let's make them all within the 3 range. Do that one. And that means that whenever I click without pressing the Shift key, when I click any of these nodules, we'll go back to those original states. So that's a quick way of recalling the states of various objects. Etc. And another preset object I can make for the envelopes. So I'll connect it to all of the envelopes we've got in here. So my first preset will be the envelopes as they are at the moment, and then I could modify them such that, for example, each successive harmonic as it goes up the frequency spectrum, although in this case it doesn't go up the frequency spectrum because of the relationships I've chosen, but you understand me hopefully. So we can modify those envelopes, and then, oops, save that preset. So this one should sound different. Yeah, and it does. And then, as I say, we'll make a preset for the U menu objects that are controlling the oscillator choice. So we could make one. We choose one module for the state that things are in at the moment. We could maybe choose all sine waves for all of the oscillators as a different preset, and different again for the third. This should be a fairly abrasive one because they're all non-sine waves. So with this you have a means of generating some quite complex timbres and some quite diverse timbres through a combination of controlling the choice of different oscillators, the envelope shapes for each of the oscillators, and the harmonic relationships or inharmonic relationships between the various oscillators. That in conjunction with being able to change the length and obviously choose the relative amplitude according to the velocity you've chosen, and to be able to store that, gives you quite a powerful instrument in itself. So for your final projects you might want to try integrating this with other aspects of synthesis that we will look at. So that's subtractive synthesis using filters. Actually, we've already looked at filters when we were using the percussion synth, and delays and other effects processing, and of course using this in conjunction, for example, with a sequencer. Just one more thing, I realised I made a mistake earlier, with apologies. I forgot to include a decimal point after all of these numbers in the multiplication objects. So when I was claiming that you would be getting some interesting non-integer multiple relationships between these harmonics, I lied. So again, I'm sorry about that. So we'll remedy that now, and hopefully you'll hear a bit more of a difference. There we go. So if I now send those values into here, we should hear a bit more of a difference. There you go, that sounds a bit better. That's certainly not how it sounded before. And going back to the issue I said about trying to detune some of the pictures from integer multiples, I think one of these is preset appropriately. There you go. So maybe we will hear a difference now. There you go. Okay, that sounds different from this, and is altogether richer. So offsetting some of these partials will give you a kind of extra enlivened quality to the sound, which is very valuable. So perhaps you'll want to remember that if you choose to make this for your final patch.